Let's see how Chia works in practice. Chia is a prototype tool realized as a Java 7 standalone application. After executing the command java-jar chia.jar, the command line application is started. When the tool is executed, the automata mode is firstly enabled. To see all the possible commands, it is sufficient to press tab. By typing help and the name of the command, a short description of the command and its parameters is provided. Let's assume that we are developing a sending message system. We may load our initial, incomplete and still to be refined design, using the command load model. In this specific case, our model is stored in the model.xml file, which is located in the Chia examples. Sending message. Automata folder. We can see the model which is currently considered by Chia using the command display model. In our example, the considered model has one initial state, the state Q1, the black box states send1 and send2, and the accepting states Q2 and Q3. The state Q1 is the initial state of the system, that is the state from which the computation starts. The states send1 and send2 are black box states. They represent two functionalities that are in charge of sending a message. At the current development stage, we still have to design the send1 and send2 components. It could be that inside send1 the system tries to send a message using a Wi-Fi connection, while in send2 a fiber connection is used. Finally, the states Q2 and Q3 represent the failure and the success state, respectively. The transition relation specified how the state of the system changes over time. For example, when the transition 1 is fired, that means that a start input is received, the system modes into the state send1. A visual representation of the automata is the following. As a developer, we may want to know whether the model possesses some of the properties of interest. Let's consider, for example, the case in which we would like to check if, after a message is sent, it is finally delivered. We can use the command lpltl and then specify the property of interest. Is the property satisfied? Is it not satisfied? Is it possibly satisfied? As a developer, we do not want to start another development round if the property is not satisfied. Our time is important. We want to make sure that before refining send1 or send2 the property is satisfied or possibly satisfied. For this reason, we ask Chia to check if the property holds in our initial design. By running the command check, Chia provides us the desired answer. In particular, in this case, the property is possibly satisfied. By exploiting the constraint computation method, we are able to precompute a set of subproperties for the black box states. The subproperties that can be used when a replacement is designed to reduce the verification effort. The constraint is saved through the command save constraint. At this point, we start the first refinement round. We first enter the replacement mode. Then the developer designates the replacements for the black box state send1. The design can be loaded through the command load replacement. It is possible to show the replacement through the command display replacement. The incoming transition connects the state Q1 of the model to the state Q4 of the replacement. The automaton contained inside the incomplete Buchi automaton XML element describes the behavior of the system inside the black box state send1. Finally, the outgoing transitions specify how the replacement can be left. To check whether the new design satisfies the original property, it is possible to verify the replacement versus the previously computed constraint. For this reason, the constraint is loaded through the command load constraint. And the verification is performed through the command check. The property remains possibly satisfied, since its satisfaction depends on the replacement of the state send2. Note that the verification time is around 10 milliseconds, and the size of the automata generated is 4 to 4. Let's consider the case in which the verification is performed from scratch. After loading the refinement and the LTL property, the model checking activity is performed. Note that the verification of the refinement takes around 40 milliseconds. The size of the automata generated by the refinement checking procedure is 67.